Greetings to all. Today's topic is scattering of light. When the sunlight enters into the atmosphere, the atoms and molecules are present in the atmosphere. Refract. It is all possible direction. Refract in all possible direction. That is called scattering of light. The interactive particle of the medium is called scatter. Types of scattering. When a beam of light interacts with a constituent particle of the medium, it undergoes many kinds of scattering. Based on initial and final energy of the light beam, scattering can be classified as two types: elastic scattering and inelastic scattering. Elastic scattering. If the energy of the incident beam of light and the scattered beam of light are same, is called elastic scattering. If the energy of incident beam of light and refracted beam of light, scattered beam of light is same, that is called elastic scattering. Inelastic scattering, when the energy of incident beam of light and scattered beam of light are not same, that is called inelastic scattering. In nature and size of the interactive particle of the medium or scatter is Rayleigh scattering, Mie scattering, Tyndall scattering and Raman scattering. First, Rayleigh scattering. The scattering of sunlight by the atoms or molecules of the gases in the Earth atmosphere. The scattering of light falls on the atoms and molecules of the gases enter the atmosphere. That scattering is called Rayleigh scattering. Rayleigh scattering law is directly proportional to 1 by lambda raised to 4. Yes, amount of scattering, lambda wavelength. Lambda raised to 4 means 4th power of the wavelength. 1 by directly proportional by 1 by means inversely proportional. Rayleigh scattering law stated that the amount of scattering is inversely proportional to 4th power of the wavelength, lambda wavelength. When the sunlight passes through the atmosphere, the blue color is scattered in shorter wavelength and red color is longer wavelength. The shorter wavelength is greater than the longer wavelength. So this scattering causes the sky appears blue color. At sunset and sunrise, the light rays from the sun have to travel a large distance in the atmosphere than at noon. Hence, most of the blue lights are scattered away. Most of the blue colors are scattered away and only the red light which gets least scattered. Therefore, the color of the sun is red at sunrise and sunset. Mie scattering is caused by pollen, dust, water droplets and other particles in the lower surface of the atmosphere. Mie scattering is based on the appearance white clouds. Mie scattering is responsible for the white appearance of the clouds. When white light falls on the water droplets or any dust particles, all the colors are equally scattered. Which together form the white light. Appearance of clouds in white color. Mie scattering reflects at dust particles, water droplets. In all colors are in equal directions. Seven colors are there: violet, indigo, blue, green, yellow, orange, red. All colors are equal direction. So white light is scattered in all directions. Tyndall scattering. When the beam of sunlight enters in the dusty room through a window, then its path becomes visible to see us. This is because the tiny dust particles present in the air of the room scatter the beam of light. The scattered beam of light rays in the colloidal particles in the colloidal solution. That is called Tyndall scattering or Tyndall effect. The scattered beam of light by colloidal particles or colloidal solution is called Tyndall scattering. Tyndall scattering or Tyndall effect. A Tyndall effect. Then solution means light wave not visible, colloidal means visible, and suspension means visible. Raman scattering. Definition of Raman scattering. Raman scattering is defined as the interaction of light ray with the particles of pure liquids. Pure liquids are transparent solids which leads to a change in wavelength or frequency. Raman scattering is defined as the interactive particle of the transparent liquid, a transparent solid, pure solid. It leads to change in wavelength and frequency. The spectral lines are in frequency. The modified lines are called Rayleigh lines and unmodified lines are called Raman lines. The spectral lines having frequency equal to the incident ray frequency is called Rayleigh lines, and having frequencies other than the incident ray is called Raman lines. Then Stokes lines and anti-Stokes lines. Stokes lines means the lines having frequencies lower than the incident frequency. The Stokes lines means the lines having frequency lower than the incident frequency is called Stokes lines, and anti-Stokes lines means the lines having frequencies higher than the incident frequency is called anti-Stokes lines frequencies. Dear children, next class we will learn about types of lenses. Thank you. Have a nice day.